Moving right along, section 2 is about our changes in state. So how do I go from one state to the next? Because again, all those elements on that periodic table and a lot of pure substances can exist in different states. So how do I go from state to state? This first video is going to focus on going from a solid to a liquid and from a liquid to a solid. There are a lot of key terms in this section that are important to know, so make sure you're taking good notes on those. First, let's look at water. This is liquid water. It might not look like the liquid water you normally see, but it is. You can see that it is a liquid. We have our particles and they kind of slosh around, and you can see that we do have 2 hydrogens for every 1 oxygen in there. Over here is solid water. Solid water doesn't always look like what you see. This is what we call ice. But here you can see that our water molecules are in a very, very, very thought out crystalline pattern. That's right, ice is a crystalline solid, and we have a nice arrangement of our water molecules. Here we do not have the as much movement in our particles as water because our thermal energy is very low. So let's think about ice cream. I'm sure all of you have had this trouble with yourself, and that's the fact that your ice cream tends to melt. So what's going to happen is first, as you hold that ice cream, you're going to increase the thermal energy of your ice cream. Particle movement is therefore going to speed up because, again, thermal energy is the total movement of particles. So as your frozen ice cream, you're giving it energy just by holding it, transferring the heat from your hand, the thermal energy from your hand into the ice cream. It increases the movement of those particles. Those particles are going to start moving so fast that they're going to break free from that crystal structure. Once that crystal structure gives way, your ice cream melts, and that's why you get that liquid forming there. So solids to liquids. This change is called melting. I'm sure you've all heard that word before. It happens at what we call a melting point. So in a solid, you give it enough thermal energy, those particles break their structure and therefore lose the structure and liquefy or turn into a liquid, called this melting again. So most pure substances, this happens at a certain temperature. For water, that's 0 degrees Celsius or 32 degrees Fahrenheit. Going the other way around, going from a liquid to a solid, we call that freezing. Freezing is the temperature in which those particles lose so much thermal energy that they go back into their regular patterns, or if it's an amorphous solid, their irregular patterns, and they form their solid state. Freezing point for water is 0 degrees Celsius or 32 degrees Fahrenheit. You should note that freezing point and melting point are the same thing. It is just one is referring to going from a solid to a liquid, which is melting, and the other is going from a liquid to a solid, but they happen for most pure substances at the same temperature. So looking at water as our example, you'll note that the temperatures are the same for melting and freezing. Which brings us to our next point, which is how to make ice. This is a good step-by-step guide for making ice, just like I gave you a nice step-by-step guide for melting your ice cream. Water is going to lose its energy to the cold air that's in your freezer or wherever you're putting it. But basically the environment around the water is colder than the water itself, and therefore the water is going to lose its energy. The atmosphere around it is going to take thermal energy away from your water. In doing so, your particles are going to slow down. They're going to slow down so much that they start forming regular patterns, and once that regular pattern is established, that is what we now have as a solid, so it does freeze. So that's how ice is made. That concludes that. Our next video, we'll look at other changes as well.